So we've seen in the past that that this is one form of the power series. Well, another form is this. So if you look at this is exactly the same as this, except that this x here is well, you would put x minus a into this x here. That's the only difference. So if I were to give you, let's say, a function like if I were to give you a function, let's say f of x equals x squared plus x, say. If I were to ask you to apply this transformation x minus 3, then you would put this x minus 3 into this x here. So then give you x minus 3 squared, and then you would put this x minus 3 into this x here. So that would then be plus x minus 3. So what this would do to the new this transformation would move everything across by 3. So this bit here will move across to here. This bit here will move across to here. It gets shifted across by 3. You see, this transformation here moves everything across by 3. So it's very similar here. If you look at this is x here, and this is x minus a here. So it will have the effect of moving everything across by a factor of a. Because there's a minus here, you move it to the right by a. So if you look at this here, if you put, let's say, if you put x minus a here into here, and then x minus a into here, into the x squared here, that will then give you this bit here. Put this into here, that will then give you this, and so on. So by you doing this, you're in a way applying this transformation here, where you move this thing across by a factor of a. So let me give you an example, and hopefully you can see what I mean. So let's say f of x equals this thing here, but let's make a special case where this thing is always equal to 1. And let g of x, let another function be this thing here. But let's keep it simple. Let's make this thing always equal to 1. So our f of x equals this, and our g of x equals this. Just so this is exactly the same as this, except that instead of x, you have x minus 3. So when we're trying to understand something, we try and make it simple so that you can see what's going on. So when you break this up, it will then give you this. Break this up, it will then give you this. So now if you get a graph plotter and plot the first 5 terms for this and the first 5 terms for this, you will get this. So in a way, so the first 5 terms would be this red line here, and then the first 5 terms for g of x is this thing here. So you can see that everything has been moved across by a factor of 3. So this bit here gets moved across by 3. This bit here gets moved across by 3. So in a way, you're actually applying this transformation here. You're moving everything across by 3. Now, if you look at the function, so we've seen this before in the past. F of x equals this thing here. When you get to this stage here, you should realize that, well, this is in a way a geometric series where this is your common ratio. Well, a geometric series where this is your common ratio. Well, if this thing here, if the absolute of that thing is less than 1, then you know the series will converge. Well, another way of looking at this is this. When you have absolute equals less than 1, you can always visualize it like this: bigger than -1, smaller than 1. So if you look at the domain for this function, it would look like this. X has to be bigger than -1, but smaller than the number 1. So this here is our domain. So if you look at this here, this here is your radius. Your radius of convergence here is 1 for this case here, because this is your radius here. This is your radius here. This is your radius here. So your radius of convergence here is 1. And so you can actually say the radius of convergence is 1. But normally you have to investigate the endpoints. Okay, but you just state that the radius of convergence is 1. But normally you need to investigate what happens here. Sometimes, if you look at -1, sometimes it depends on the series, but sometimes it converges, sometimes it diverges. But you can always make the statement that the radius of convergence here is actually 1 for this case here. Now let's look at this scenario here. So this scenario here, g of x is given by this. Now, when you look at this, you should be able to tell that this is this is a geometric series where this is your common ratio. Well, if you make this thing here, the common ratio to be less than 1, so you can write it like this. If you make it less than 1, then you know that if you make this thing to be less than 1, if you make this thing here to be less than 1, then you know that this series will converge. So so when you see this, you can always rewrite it as this, and then add 3 to this, and then add 3 to this. That will then give you this. You see, when x is between 2 and 4, then your series will converge. So when 1, 2, 3, 4. So if x is so your radius of convergence here is still 1. The radius of convergence here is still 1. But it's the center here is 3. The center up here is 0, but the radius of convergence is still 1. The radius of convergence for this scenario is still 1, but it's centered at 3. So just bear that in mind. Okay, I will give you an example in the next video.